Okay, this has to do with the complex conjugates theorem, and it's very similar to the irrational conjugates theorem. Remember with irrationals, if we knew that 1 plus the square root of 5 was a root, we also knew that 1 minus the square root of 5 was a root. And the same thing is true. If I knew that 1 minus the square root of 5, if I knew that one, I also knew the positive. So it goes both ways. The same thing is true with imaginaries. Now, complex numbers is simply imaginary number. It basically means I have 1 plus a number plus an imaginary number. That's a complex number. So if I've got one form of it, I have the other form of it. Likewise, if I have the negative, I also have the positive. So first things first, we're going to review how to take roots and turn them into a polynomial. Then we're going to go back and deal with the imaginary numbers, which we're going to deal with the imaginary numbers, these guys, the exact same way we dealt with these ones. All right? Hopefully that doesn't bring forth too many bad memories. But here we go. So first thing, we just got to flip the roots. So if I've got a root of negative 4, that means I have a factor of x plus 4. Turn our roots back into factors. So if I've got a root of 1, I'm going to have a factor of negative 1, x minus 1. If I have a root of 7, I'm going to have a factor of x minus 7. And then we just start multiplying like crazy. So x plus 4. 4 times negative 1 is negative 4. 4 times x is 4x. X times negative 1 is negative x. X times x is x squared. And then we got, that's 4, 3x, and x squared. Okay? And then I got to multiply by x minus 7. Negative 7 times 4 is negative 28. Negative 7 times 3 is negative 21, so negative 21x. Negative 7 times x squared is negative 7x squared. Alright, and then the last one on there, x times 4 is 4x. X times 3x is 3x squared. And x times x squared is x cubed. So when you add all those up, you know that your polynomial is going to be f of x equals x cubed minus 4x squared. 21, negative 21 plus 4 is what, 17? Yeah, negative 17x minus 28. And yes, Mr. Hunter used to count on his fingers a little bit. Sometimes it helps. 17, 18, 19, 20, 20. Good. So once we multiply all that out, that is our polynomial with roots negative 4, 1, and 7. Now, that's not the only polynomial we can do with that. There are other ways of doing it, but this will have a leading coefficient of negative 1, and it is the smallest degree that has these roots. So we could have a degree of 4 or something along those lines. All right, here we go. Let's do number 10. Number 10, same idea. Ooh, I didn't pause it between. So I've got a root at 10, so I got a factor at x minus 10. And I got a root at negative square root of 5, so I've got x minus the square root of 5. And I have x plus the square root of 5, which that's really nice because that's a difference of squares. And a difference of squares, when I multiply it out, remember, just turns into x squared plus negative 5, minus the square root of 5 squared, which just happens to be 5. Alright, quick proof for that real quick. X minus square root of 5, x plus the square root of 5. When I multiply those out, x times x is x squared, x times the negative 5 is plus square root of 5x. Negative 5 times x is minus square root of 5 times x. The last, negative 5 square root of 5 times square root of 5 is 5. Alright, those two cancel out, so it's x minus 5. Alright, hopefully you're starting to see that, pardon me, see that a lot quicker by now, but if you're not, just multiply it out the long way, you'll always get it. Alright, last but not least, we need to multiply out x times, helps if you don't use your eraser to write, x minus 10. So, negative 10 times negative 5 is positive 50. Negative 10 times, so that's negative 10x squared, which I'm actually going to put a little space right here. Negative 10x squared. Because there's no x in the middle, I'm going to put a little space, and I'll show you why in half a second. So x times negative 5 is negative 5x. Well, it fits right there. And x times x squared is x to the third, so that's positive x to the third with a little space right there. And so we add them all up. F of x is x cubed minus 10x squared minus 5x plus 50. That is the lowest degree function with a leading coefficient of 1 that has negative 10 and the square root of negative square root of 5 as roots. All right. On the next one, we're going to talk about the imaginary ones, but just give me just a second. All right, for number 11, now we have an imaginary number. We have 3 minus 1, which means, by definition, we also have 3 plus 1. 3 plus I. I'm sorry, we have a 3 minus I, therefore we have a 3 plus I. So we have to turn those 3 roots back into factors. So we have x minus 8. We also have x minus 3 minus I. And we also have x minus 3 plus I. Okay? So I basically treated this as like one big number. I did x minus that number. And I did this one, x minus that whole number. Alright, same idea. So I've got f of x equals that. Whoop, use the right color. So here we go, f of x equals x minus 8. And then, just like the radicals, we'll reorganize it a little bit. This is, when I distribute this negative right here, I get a minus 3 and a plus I. And when I distribute the negative here, I get an x minus 3 and a minus I. And then I will go ahead and put parentheses around the left too, because those binomials are the same. And now I have a difference of squares. Alright? I have the same thing on the left, I have the same thing on the right, and then I have different signs. I got one positive, one negative. So therefore, this is a difference of squares. Ooh, I forgot my parentheses around my x. So therefore, f of x equals, drag down the x minus 8, I get x minus 3 squared minus I squared. Alright? Feel free to pause and stare at that for a minute. If you want to multiply them off out to the right, they work just the exact same way as the radicals did. Alright? Anything else? So here we go. F of x equals x minus 8. And we're going to multiply that out. So we're going to get, if I do x minus 3 times x minus 3, I get x squared, I get a negative 3x, I get a negative 3x, I get a positive 9, and when I multiply out negative I squared, remember, I squared equals negative 1. Alright, that is a rule you're going to have to memorize at this point. I squared equals negative 1. So, if I have a negative 1, I now have a positive 1. So my I went away. So let's clean it up and multiply everything else. So I've got f of x equals x minus 8. I have x squared minus 6x plus 10. And the last thing we have to do is multiply everything out. So negative 8 times 10 is negative 80. Negative 8 times negative 6 is positive 48. Negative 8 times x squared is negative 8x squared. Then x times 10 is 10x. X times negative 6x is negative 6x squared. And x times x squared is x cubed. So, when I combine all my terms, I get f of x equals x cubed minus 8 and 16 is 14, so 14x squared plus 58x minus 80. And there you are. If I were you, I would, on a separate sheet of paper, try and do this one on your own again. Alright, even though you just watched me do it, grab a separate sheet of paper and try to do this on your own. If you get stumped, come back and see it. And I would keep doing that until you finally get through the whole thing on your own. All right? I would do that over and over until you get it right. Let's bump down to number 12. All right, number 12 has finally reached the point of pain in the butt. So we have a root at 0. We have a root at 2 minus the square root of 2. So that means we have 1 at 2 plus the square root of 2. We also have it 2 plus 3i. So that means we have 2 minus 3i. All right. So we have 5 roots to deal with. So here we go. I've got f of x equals, well, x minus 0 is simply just x, which that's nice. And let's do it with the radicals first. Not that I have to, I'm just going to do it first. So I've got x minus, parentheses, 2 minus the square root of x, 2. And then I also have x minus, parentheses, 2 plus the square root of 2. Well, those are my radicals. Now let's do the complex numbers. I got x minus 2 plus 3i, and I got x minus 2 minus 3i. Okay, and we are going to do the same thing as we've done before. We're just doing it twice. There is nothing new here other than the fact there is more to stare at. All right, which, don't get me wrong, is a pain in the butt. So we'll start off by distributing all those negatives. So we got f of x equals x. So for this one we got x minus 2 plus the square root of 2. For the next one we got x minus 2 minus the square root of 2. For this one we got x minus 2 minus 3i. But that's a really ugly negative, so let's do it again. X minus 2 minus 3i. And then we got x minus 2 plus 3i. And then I'm going to go back in here, and I'm going to pair up those front two terms. So I got an x minus 2, I got an x minus 2, and I got another x minus 2, and another x minus 2. Now, I know I got 4 x minus 2's, but don't think, oh, I can do all these at once. I'm still going to do with the radical one separate from the complex one, okay? But it's the same thing twice. So, since these are both difference of squares, remember I can write them as the square of the left one minus the square of the right one. So, we've got f of x equals x. Now the square of the left one, x minus 2, is x minus 2 squared minus the square of the right one. The square root of 2 squared is 2. Okay, that takes care of the first two. The next two, we still write it as the square of the left one, which is x minus 2 squared, times the square of the right one. So we're going to do minus 3 squared is 9, I squared is I squared, which we'll deal with an I squared in a second. Cool? Feel free to pause and look at that, make sure we're all on the same page. Alright, next line, we're going to multiply that out and start combining terms. So we got f of x equals x. X minus 2 times x minus 2. That's x squared minus 2x plus 4 minus 2. And the one on the right is again, if we multiply it by x minus 2, x squared minus 2x plus 4 minus 9i squared. Sorry, I whistled on that. Remember, I squared equals -1. So, this turns into a -1, which turns that positive. So we're going to put plus 9 right there. Okay, we got a headache yet? If so, go take some Tylenol and come back. If not, let's keep going. F of x, sorry, that was kind of crass. That was kind of rude. So, here we go. Let's combine this one to the left. We got x squared minus 4x plus 2. And on the right side, we've got x squared minus 4x. 9 plus 4 is 13. Cool. So I'm going to go ahead and multiply one of these out. I'm going to go ahead and distribute the x. So this becomes, and I'm going to put it right down here. This is just, I'm kind of skipping a step a little bit, but if I distribute that, I get x times x squared is x cubed. X times negative 4x is negative 4x squared. And x times 2 is 2x. The only reason I do it that way is I'm just saving myself a little bit of room, because I now have to multiply these guys out. So 2x times 13 is 26x. 2x times negative 4 is negative 8x squared. 2x times x squared is positive 2x cubed. Negative 4x squared. Negative 4x squared times 13. 13 times 4 is 52. Yes. That's negative 52x squared. Negative 4 times negative 4 is positive 16, so that's positive 16x cubed. Negative 4x squared times x squared is negative 4x to the fourth. And then last but not least, x cubed times 13 is 13x cubed. Negative 4 times, x cubed times negative 4x squared is negative 4x to the fourth. Negative 4x to the fourth. Is that right? Yep. And then x cubed times x squared is x to the fifth. So here we go. For this one, to have those roots and a leading coefficient of 1 and the lowest possible degree, we have x to the fifth minus 8x to the fourth. 13 and 16 make 29, so it's 31 plus 31x cubed. Negative 52 minus 8 is negative 60 minus 60x squared plus 26x. And like I said, if you have a headache, I'm sorry. Here, let me do that to where I'm not covering up the last bit of work. And again, just like the last one, if I were you, I would on a separate sheet of paper try this one out a couple of times. If you can do this problem on your own without staring at it, even if it takes you 4 or 5 tries, you can do any problem like this we throw at you. Alright? I promise. Yes, there's a lot to look at. You're big boys and girls. You can handle it. I promise. Here we go.